Hello everyone, I'm Wang Tao from University of Chinese Academy of Sciences. It's my honor to be here and talk about our work understanding device integration bugs in smart home system. A smart home is a residence that uses internet-connected devices to enable the remote monitoring and management of appliances and systems such as lighting and heating. Smart home technology, also known as home automation, provides homeowners with added security, convenience, and energy efficiency. It allows them to control smart devices simply with an app on their smartphone or other networked devices. Smart homes have been rapid growth in recent years. The blue bar chart shows the number of households with smart home systems. At the end of 2018, there were more than 200 million homes globally with at least one smart home device. By 2023, there will be an additional 100 million smart homes. The line graph in yellow shows the annual consumer spendings. We can see that this is a steadily increasing trend. Therefore, the reliability of smart home system has become a problem we need to pay attention to. There are more and more smart home systems in the market. They allow users to control different kinds of devices. Most of them have powerful automation engineers, friendly UI, and open interface to integrate devices. To make a device connectable and accessible, developers have to contribute a device integration. Device integration builds the bridge between the device and smart home system and usually defines an Internet of Things domain. Developers should handle the device lifecycle process, including the device discovery, initialization, execution, and release. We can find that developers often ask questions during the device integration development. Bugs can also happen in the development. We call device integration bug as iBug. iBugs can seriously affect users' experience. They can cause device unavailable, inconsistent states between the device and that with the system. They can also cause unexpected system behaviors. There is little knowledge about iBugs of smart home systems in the literature. To understand device integration bugs, we conduct an empirical study to characterize iBugs and try to investigate the root cause, fix strategy, and trigger condition of iBugs. There are currently three popular smart home systems: Home Assistant, OpenHub, and Sensing SmartThing. They all allow developers to integrate new devices. However, the SmartThing is closed source and it does not facilitate the researcher's analysis. Among them, the Home Assistant has better issue organization and community activity. Therefore, we select the open source smart home assistant as the target system, considering its popularity and open source nature. Home Assistant is the most popular smart home project, which has supported thousands of device integrations. Besides, Home Assistant also has a special design. It separates and maintains the device SDKs from the device integration. This will filter out some device-related issues, such as incorrect communication protocols and incorrect wrapper of device APIs. Therefore, it is straightforward to analyze and locate iBugs in Home Assistant. We manually went through issues and pull requests of the Home Assistant repository on GitHub to collect iBugs. First, we concentrated on the closed bug reports with the label integration. We selected issues in the second half of 2020, and we obtained more than 2,000 closed issues. Next, we searched for each issue's associated merged pull request, which indicated that the issue was potentially a real bug, and we obtained 831 bug reports. Next, we iteratively sample batch of bug reports and doing root cause analysis on them. We did labeling and solve conflicts in each iteration until we reached the state of saturation where no new labels appeared. We summarized 23 atomic categories of root causes and divide them into 7 aspects based on the device life cycle model we proposed before. The first is device-related bugs. In the discovery stage, the device integration is responsible for obtaining some device information. The information is used to connect device in the system. The purpose of initialization is to make a device integration ready for managing the corresponding device. If required, authentication should be established. The execution stage is responsible for communicating with remote devices and synchronizing device states. When a device is no longer in use, the allocated resources should be released properly, such as terminating the monitoring process and cancel timers. The bugs related to error handling occupy the largest number. The others include some common bugs also happen in other softwares, such as API breaking change, dependency conflict, and so on. Users can integrate incompatible devices into the system. These devices are partially spotted or not spotted at all. For example, the device integration only supports hit and go, the two modes during the development. When a user accesses a device with additional mode auto, it will throw exceptions when user calling the mode auto. 13.6% iBugs are caused by accessing incompatible device without clear promos. The smart home system should give a clear promote when a user enters an incompatible device. Configuration error and generating incorrect device information related iBugs can happen during the discovery stage. Each device within the system must have its unique ID. Developers can generate duplicate IDs. Some developers use privacy information as the unique ID, such as MAC address. However, some devices do not expose their MAC address, making the ID assignment a failure. We found that the main cause of generating incorrect device information is that the accessed device does not have a unique ID, and the developers should not use privacy information as the unique ID and should also avoid generating duplicate IDs. Developers can forget to keep the authentication of the device. Users can operate the target devices after connected the device within the system. However, after 1 hour, when he wants to turn off the device does not give any response, and the system throws an error invalid authentication credentials. Therefore, smart home systems should inform device integration developers of the existence of an expired device authentication. The integration defines a time-consuming task in the main thread, and it will slow down the system. We found that developers can set time-consuming tasks in the main thread, and it will block the system. Background threads should be delegated to execute such tasks asynchronously. Device integrations can forget to release resources or do incorrect release. For example, the integration only removes some tasks after release, and it ignores the release of some variables that may cause the device to be re-added. Therefore, the system should provide some utilities to help the results release process or introduce an automatic garbage collection mechanism. Error handling related iBugs can also happen, like incorrect response and insufficient error handling. The developer did not take into account the case that the target field depth of the response is empty, and the further processing leads to non-pointer exception. These root causes are similar in other software applications, such as API update, cost break change, general code error, dependency conflict, and so on. Fix of device integration bugs are highly related to their root causes. We found that 15 out of the 23 atomic categories have frequent fixed patterns. For example, the bugs caused by forgetting to keep authentication can be fixed by the monitoring session expirations errors with the code below. Therefore, researchers can develop automated fixing tools for iBugs based on our summarized fixed patterns. We found that following 5 conditions can trigger iBugs: load or reload integrations, frequent request, invoke device service, and internet interruption delay and recovery. We can perform systematically testing based on these trigger conditions, such as reloading, the integration, error injection, and stress testing. For example, we can inject network delay when we invoking device service normally. In conclusion, we conduct the first empirical study on 330 device integration bugs and obtained lots of interesting findings that can be used in iBug detection, software testing, and provide a guide for developers, system designers. More details such as root causes, fixed patterns, and the tree conditions can be found on our GitHub. That's all. Thanks for your listening.